In my channel. We're going to start on the next part of radiology. We're going to look at radiographic findings. So the key features to look for is size, borders, geometry, and location. So when we're talking about size, we're looking at the size of millimeters. So you want to look at, you know, the width and height of uh, pathology you may see, and the best thing is reported in millimeters. That way you can see if there's any growth. You want to look at the borders. So you want to see if the borders are defined or not defined, and geometric shape. Um, Location is very important, so you have three main areas of location. So if the epicenter appears superior to the inferior alveolar nerve or the mandibular canal and coronal to the tooth, it's going to be odontogenic in origin. So think about odonto means tooth. So if it's coronal to the tooth, it's probably going to be tooth related, so odontogenic origin. If it's below the canal, the epicenter that is, it's going to be non-odontogenic, meaning it's not tooth related. And if it's going to be in the canal, it's going to have three different types based on the tissue type that it's involved with. So it could be neurovascular or smooth muscle elements. So let's first look at size. So if we look at size, we can have this first one we're looking at right here, where it's one radiolucency. It's localized, so solitary, meaning by itself, is the same thing, or focal, where it's within one region, would be another way to state the same thing. So solitary or focal is defined as one lesion. You're going to record again the width and length of the lesion. And in the case of this image that we're showing right here, this is an example of a Staphny bone defect. You can have a diffuse lesion, which basically means that there are going to be multiple lesions that are going to appear in one jaw. So it could be in both quadrants of that jaw, or um, it could just be in one jaw. So in this case, we have a bunch of lesions that are appearing here, some that are appearing here, and so this would be considered a diffuse lesion. Generalized means that it's going to have to be in at least three quadrants, meaning that it's going to be in both the mandible and the maxilla. And if we look at this image, we see that there's a lesion right around here. There's one right here. We have some more that are showing up here, some that are showing up right here, and we see it all over the place. So this is an example of a OKC that's present in all quadrants. Now, if we see a symmetrical lesion, all this means is the lesion is a mirror image, meaning that like what you see on the right side is going to be on the same location on the left side. And the example of this is cherubism, where we have multiple lesions throughout, and it looks kind of like this scattering of a bunch of random lesions on this side that are appearing also on this side. So basically, there are these multiple um, radiolucencies that are appearing on the mandible, going all the way up on both sides. Now let's look at borders and what that means. So you can have a couple different ways. So you can have a border that's well defined, distinct. Now if we look right here, we can almost get a pencil and draw a line around that border right there. And this would be considered a well defined or distinct border. And the example that I'm showing right here, it's an antral pseudocyst, and the next is going to be a sclerotic, well corticated border. So if we look at this border right here, we can see that it's kind of following that same path. It's a radio-opaque border. And when we think sclerotic, we have to think it's been around for a long time, meaning that it's a cyst or a benign tumor that's just been hanging out for a long time. So we have this kind of radio-opaque border that's forming around it. A scallop border, on the other hand, when we think of scalloping, it's going to be something that's going to have kind of this not free form or consistent pattern. So it's going to have a lot of ups and downs or jaggedness. So if we look at these three images, we see that the the border is actually kind of fitting between the teeth. So it's kind of running in between each tooth. And that's the roots of the teeth, that is. And that's what would be considered a scallop border. And so in the case of this, we've got a bone cyst right here, and some of these are OKCs. So now punched out almost looks as though somebody got a hole puncher and decided to punch little holes. Now, if we look carefully, we see this is a good example of a punched out. They're going to have a very sharp boundary, but no apparent reaction to the host bone. This is another example of a punched out border. These are commonly seen in multiple myelomas or Langerhans cell histiocytes. Um, the next one we have right here is a peripheral radiolucent rim around a radiopaque lesion. The beauty of these types of lesions are they can easily be removed. They're not going to cause any problems with removing them. So if you want a sort of lesion, this is the one you want because it means that you can easily take this sucker out. So now if we look at these images and kind of think back to our well-defined, in the case of this, we know that approximately where the lesion is, but there isn't a line that I can easily draw to say that this would be well-defined. Instead, this is going to be ill-defined, poorly marginated. Um, and so there is this kind of zone of transition where we see abnormal to normal. And so it's not really an easy or clear, concise lesion, as we saw with a well-defined. And then there's also ragged moth-eaten. Now, if we look at this image right here, we can see that it kind of looks like somebody chewed it up. So that's kind of where they came up with the moth-eaten, and ragged is kind of like a very simple way of saying, hey, this does not look good. Now, if we think of something like these types of lesions, these are going to indicate a severe inflammatory disease or malignant neoplasia. So this is going to be something that's going to be of concern because this would, if it has cortical involvement, this is going to indicate that it is something that's aggressive or rapidly destructive pattern, which in both cases like this, we would, be really worried if we have this sort of lesion. So now let's look at geometry. So we have round ovoid, and that's kind of obvious. Like if we look at this lesion right here, it's pretty much a circle. And if we look at this one right here, this is the same thing. The only difference is in this case we have a radiolucent, circular, which would be more likely a fluid-filled cyst. In this case right here, we have a radiopaque, round, not fluid-filled lesion. Now we can have irregular lesions like this one right here, and this guy right here. And these are going to be basically lesions that in some area they're going to have a larger diameter, and then in other areas they're going to have smaller diameters. It's going to basically mean that there is some level of aggressiveness, and that's really it in terms of an irregular shaped lesion. Location. So you can have a central lesion, which is basically going to arise in, as it sounds, the center of cancellous bone of the jaw, where you have cortical bone still on both sides, or you can have it a peripheral, arising peripherally, which would mean that if this is the center, this would be the peripheral where it's outside, and it's going to arise in the alveolar crest. It's going to have a wide zone of transition between normal and abnormal, and this is going to be something like a carcinoma. If it's localized enlargement of crestal bone, it's going to be an osteosarcoma or chondrosarcoma. Now we can have a periosteal, which it's going to have kind of like this sunburst or sun ray pattern where it almost looks as though you have like little hairs on end. And these are going to arise in the periosteal compartment of bone. So thinking periosteal, it's kind of obvious. These lesions, of course, are not going to be something good. So this is going to be bad, and they're going to be kind of like similar to what you see in an osteosarcoma. You can have circumcoronal, which, if you think about it, circum means around, coronal means crown. So it's going to be something around the crown that we see right here. It's typically developed from a reduced epithelial enamel epithelium. So if you refer back to histology, you can kind of pop that in your head what that means. And in the case of this, it's going to be a dentigerous cyst. If it's infiltration of the follicular space by another lesion, that's an odontogenic keratocyst. Now we can have it periapical, which Peri means around, apical means the apex of the tooth. So if we look, this is around the apex of the tooth. And this is an osteolysis. This is going to result from inflammatory products or an inflammatory exudate. We can have an interradicular, which would mean between the roots. So we see that it's between the roots and pretty straightforward. Now, if we're looking at architecture versus texture, architecture is something that's only applicable to radio-opaque lesions, and that should say refers to internal structures of a lesion. Texture, on the other hand, refers to radiolucence. So let's look at some examples of architecture. So right here we have this unilocular lesion, and uni means one, locule, so it's a single compartment or locule. We could have a multilocular on the other hand, where if we look at this, this is going to be a lot. And so multi meaning many locules, compartments, and that's pretty straightforward. So the types of them, of multilocular, you can have your soap bubble, your honeycomb, and your tennis racket. So if we look at the three images right here, it kind of defines it pretty well. Soap bubble, if we think of soap bubbles, they're going to be circles, but they're going to be of different sizes. So if you see a lesion that it's going to be a bunch of circles, but they're not uniform sizes, this is going to be a soap bubble. A honeycomb, on the other hand, they're going to be many small circles, but they're all uniform sizes. Tennis racket, it's kind of like this pattern that it's a bunch of squares, kind of like a tennis racket. So let's look at the soap bubble. So as I said, it's multiple overlapping compartments. If we look at right around here, we see that there's all these random sized circles. And this is going to be seen mainly in your OKCs or your ameloblastomas. Now, if we look at the honeycomb, if we look in this area right here, we see that each of these circles are about the same size. It's very uniform throughout. And this is typically going to also um, indicate an ameloblastoma. Less frequently, it's an intraosseous hemangioma. You can have a spider web, which are basically septae that radiate from the central body. So if we look at this kind of region right here, we see that there are many different kind of branching off pattern that we're kind of seeing in this vicinity. And this is also seen in ameloblastomas. Tennis racket, of course, is going to be kind of the easiest one where the septae are aligned at right angles to each other, kind of think of a tennis racket. So if you see something that's like more of a geometric pattern or a bunch of boxes, if we look at this, we see kind of like a lot of little squares kind of popping out. And this would be the tennis racket pattern. It's typically seen in odontogenic myxoma. Now let's go into texture, or some examples of texture. So we've got homogeneous, which, you know, think of your general chemistry. Basically, that means it's uniform throughout. So if we're looking at this, we see that it's a very uniform pattern that we see in both of these. Now we can have multilobulated, which would be multiple compartments. So it's a conglomerate of multiple lobules, and they're going to be in a cluster. So if we look at this image right here, ignore that this arrow right here, but if we look at this, it's basically a cluster of lobules. And so this is an example of a calcified submandibular gland. Now the ground glass appearance, this is one of those ones that I have a hard time seeing. So the easiest way to think about it is think about when you're looking at slides in biology and you had the frosted end, which it kind of looked opaque, but it was like this whitish color, but it's not like a pure white color. If we look right here, we kind of see that same thing, and that's what they're calling ground glass. And this is an example of fibrous dysplasia. Now, orange peel, if we look at this and kind of think of like what stippling looks like, it's kind of the same thing where it's like this spotted pattern that you see all along here. And that's basically an example of a late stage fibrous dysplasia. And So this would be an example of an orange peel pattern for the texture. Next is a cotton wool pattern, and I just like to think this looks jacked up. I mean, it's a bunch of dense patches that are of sclerotic bone. If it's a local response, it's going to be condensing osteitis. If it's a wide, it's sclerosing osteomyelitis. So if you think if it's local, it's got to be condensed, so it's in one area. While if it's wide, it's everywhere, so that's going to be sclerosing. So everywhere is going to have sclerosis. You can also have it develop in later stages of fibroosseous disorders like florid cemento osseous dysplasia or Paget's disease. This is really important because Paget's disease, it comes up on the boards. It's also like a common test question. You can have radiolucency with radiopaque flex or foci, and that basically means that you have a radiolucency, within a radiolucent lesion, you have 50% radiopaque particles. So if we look at this, we're seeing that this is a radiolucent lesion, but then you have all these like random radiopaque particles. And the key to this is you have less than 50% radiopaque particles inside this lesion. And they can be clustered in one part, or they can be throughout. Like if we look at this example right here, we see that there is this kind of light radiopaque pattern, and it's clustered in one area. Well, in this one, it's like jacked up, and radiopacities are all over the place. You can have a mixed radiolucent with a radiopaque, which would be like a 50-50 mix. And if we look at this, it's kind of like half and half of radiolucence and radiopaque. Same thing as seen right here. You can have root divergence, and this is going to be caused by, something that's a slow-growing benign cyst or neoplasia. So if we look at these examples, if you think about it, anytime we have some sort of cyst that's in there, it wants to grow. So naturally, the teeth are going to have to move out of the way. Floating air in air, it's I mean, it's kind of obvious. If you see a tooth that's just hanging out there and there's no bone supporting it, I mean, the name gives it away. It's floating in air, so pretty straightforward. Um, no, this is one of those ones that you just gotta memorize. Um, Root resorption associated with blunt pressure. It's going to be caused by cysts and benign neoplasias. It's going to be a mechanical response from the apical end upward to the occlusal end. So if we look at this blunt pressure is being applied and it's acting on the root itself. We don't really care about this crown right here. But if we're looking at this cyst is applying pressure on these two roots and destroying the roots. Now the image right here with this arrow right is pointing to a short root anomaly. The roots are tapered to the end like it normally be, having the bottom part of the root being sawed off. And this is called a short root anomaly. The roots do not fully develop in this case. They're tapered all the way to the end of the normal root. This image is another example of blunt pressure where we see that it's pushing against the roots and causing them to resorb. You can also have circumferential root resorption. And if we think about what that means is it's going to be around the root, and we see that the root looks very spiky, and this is kind of indicative of circumferential root resorption. Now you can have cortical expansion, and basically what that means is you have some sort of benign lesion that's going to keep growing, and the cortical bone is going to expand. And if you look at it, it hasn't perforated yet. And that means that's because this benign lesion is growing at a rate that there's enough time for cortical bone to be laid down as the lesion continues to grow. Now, cortical perforation, on the other hand, as the name says, now we've broken through the cortical bone. So this would be a malignant neoplasia, some aggressive benign lesions, and it's just a result of the lesion growing faster than the cortical bone that can be placed, and as a result, you break through the lesion, or the lesion breaks through the bone. You can have a periosteal reaction. This is commonly known as onion skinning. So if we look at this, we see that there's a periosteal bone that's continually being added and giving this sort of pattern that there's like layers of an onion. You can have a periosteal reaction, and this kind of we saw before. It's a sunburst speculation. Basically, it's caused by a rapidly growing malignant tumor that perforate out the cortex and the soft tissue. So this image right here is kind of showing that sunburst pattern in a 2D form. Now, if we want to see it in a 3D form, if we look at the bottom right here, it's kind of like this explosion on the chin. You have a periosteal reaction again, and this is called hair on end. So the first one right here is speculation, that's periosteal. The next one's hair on end, where you kind of see it looks like the hairs on your arm when you get cold and they're standing upright. And this is mainly associated with sickle cell anemia and thalassemia. We have very fine, short striae projecting upwards perpendicular to the surface of the structure. So again, think about when you're cold or you're having that feeling that your hair ends up kind of going straight up on your arm. And then lastly, you can have a Codman's triangle, which is another periosteal reaction. And this is going to be mainly associated with osteosarcoma. And it's a growing tumor that breaks through the cortex at the edge. It's going to cause the periosteum to lift. So if we look at this right here, this is what Codman's triangle is, this kind of triangle right there. Alrighty, I hope you guys liked the video. If you have any questions, comments, leave them below. Please subscribe to my channel. And happy studying.